graph. A graph G V comma E, a graph G V comma E where V is the vertex set, E is the edge set. This graph is null graph if the vertex set is empty, edge set also empty. Okay? So a graph G V comma E is null graph if the vertex set is empty, also edge set is empty. Then the graph is null graph. Okay? Next, isolated graph. Isolated graph. A graph G V comma E is isolated graph if the vertex set is non-empty but edge set is empty. There is no edge in this graph, but the vertex set is non-empty. Okay, if the vertex set is non-empty but the edge set is empty, then the graph is isolated graph. Okay, a graph is isolated graph if vertex set is non-empty but the edge set is empty. But in null graph, the vertex set and the edge set both empty. Okay, see. For isolated graph, one example. See one example. These are the vertices. Suppose these are four vertices. These are four vertices: V1, V2, V3, V4. Okay. There is no edge in this graph. There is no edge in this graph. So V equals to the set V1, V2, V3, V4. This is the vertex set. And the edge set, there is no edge in this graph, so edge set equals to 5. This is one example of isolated graph. So in isolated graph, degree of each vertex V1, V2, V3, V4, degree of each vertex is 0. So degree of each vertex in isolated graph is 0. There is no edge, so degree of each vertex in isolated graph is 0. Okay. Next, bipartite graph. Bipartite graph. A graph, a simple graph, G V comma E is bipartite graph if the vertex set, if V can be partitioned into two distinct subsets V1 and V2 such that every edge in G connects every edge in G connects every edge in G connects one vertex from V1 and another vertex from V2. Okay? So a simple graph G is bipartite graph if the vertex set can be partitioned into two distinct vertex subsets V1 and V2 such that every edge in G connects one vertex from V1, another vertex from V2. Okay? So bipartite graph, it's simple graph, and the vertex set can be partitioned into two distinct vertex subsets V1 and V2, such that take any edge from that graph, you will find two vertices, one from V1, another from V2. See, suppose this is one graph, and suppose this is one graph. Suppose this is vertex V1, this is V2, V3, V4, V5. Okay, this is the graph G. Now, for this graph, what is the vertex set? V equals to the set V1, V2, V3, V4, V5. This is the vertex set. Now, we can partition this vertex set V into two distinct subsets V1 and V2, such that V1 contains V1, V2, V3, the vertices V1, V2, V3, and the vertex subset V2 contains only V4 and V5. V4 and V5. So V is partitioned into two subsets. This is subset V1, this is subset V2. Now take any edge. Suppose this is the edge. You can find one edge, one vertex, one end vertex from V2, another end vertex from V1. Okay? Take this edge, one end vertex from V1, another end vertex from V2. But if we join these vertex, if we join V4 and V5, then this graph is not bipartite graph, because for this edge, both the end vertices V4 and V5 from the vertex subset V2. So this graph is not bipartite, but this graph is bipartite graph. Okay? Next, complete bipartite graph. Complete bipartite graph. This is bipartite graph, and every edge of V1, suppose this is the graph G equals to V, E, this is the bipartite graph, and the vertex set V is partitioned into two vertex sets, subsets V1 and V2. So V is union of V1 and V2, and V1 intersection V2 is null set. So V is partitioned into two distinct subsets V1 and V2, and every edge of G, one end vertex from V1, another end vertex from V2. This is bipartite graph. Okay. Now it is complete bipartite graph if take any vertex from V1, you can find is, suppose this is one graph. See, suppose this is V1, V2, V3, V4, V5. Now from V1, suppose here the vertex set vertex subset V1 is the set containing only these three vertices V1, V2, V3, and V4, V5 in the set V2. Now take any vertex from V1, suppose this is V1. Now create edge from this vertex V1 to all the vertices of V2. Similarly, from V2, you have edges from V2 to V4, V5, from V3 to V4, V5. So it is complete bipartite graph. So in complete bipartite graph, every vertex in V1 is connected to all the vertices of V2. Okay? So in complete bipartite graph, every vertex of V1 is connected to all the vertices of V2. Okay? Similarly, every vertex of V2 is connected to all the vertices of V1. So what is complete bipartite graph? It's a bipartite graph. So the vertex set is partitioned into two distinct vertices, vertex subsets V1 and V2. So V equals to V1 union V2 and V1 intersection V2 is null set. Now every vertex of V1 is connected to all the vertices of V2. Every vertex of V2 is connected to all the vertices of V1. So it is complete bipartite graph. This is one example of complete bipartite graph. This graph is K2, 3. K2, 3. This is complete bipartite graph. Vertex set is partitioned into two vertex subsets V1 and V2. One vertex set contains only two vertices, another three vertices. Okay, so this is complete bipartite graph. So one subset has two vertices, another subset has three vertices. This is K2, 3. This graph is complete bipartite graph having 5 vertices. One vertex subset has two vertices, another has three vertices. So this is complete bipartite graph. Now question is, draw this graph, complete bipartite graph K2, 2. So it has 4 vertices. One subset has two vertices, another has two vertices. From this vertex to all is to all the vertices of this subset. This is complete bipartite graph K2, 2. This is complete bipartite graph K2, 2. This is complete bipartite graph K2, 3. So see, in K2, 3, number of vertices is 2 plus 3. Number of vertices is 1, 2, 3, 4, 5. Number of vertices is 2 plus 3. And number of edges is 2 into 3. Number of edges is 2 into 3. 6. 1, 2, 3, 4, 5, 6. Okay. So in complete bipartite graph Km, N, this is complete bipartite graph Km, N. Number of vertices is M plus N. Number of vertices is M plus N. And number of edges is M into N. Okay. So in complete bipartite graph Km, N, number of vertices is M plus N, number of edges is M into N. Okay.